here we have explained a little bit of the chemicals being used in the water treatment plants, ETP and STP. For example, alum is a type of chemical compound usually found in an hydrated double sulfate salt, and its general formula is XClSO4 twice dot 12H2O, wherein the most common alum available in the market is the potassium alum, which has a formula of KAlSO4 twice dot 12H2O. This is a fast flocculator or a coagulant. Now comes the polyelectrolytes. Polyelectrolytes, as the name suggests, are polymers whose repeating units bear an electrolyte groups. It may be polycation or polyanions. Cation means the compounds with positive charge, anion means compounds with negative charge. Generally we use polycations, which because it's considered that all the impurities and bacteria bear negative charge, so it's easier using the polyelectrolytes having polycations to get the flocks and coagulation done. And polyelectrolytes are also referred to as clarifiers, and sodium styrene sulfonate is an example of a polyelectrolyte. Clarifiers are slow coagulants or flocculators, wherein alum is a fast flocculator or coagulant. If you're using clarifier, you can, instead of the drying beds, you can have big mesh filters also, and it will not clog the filter. You can clean the outer surface of the filter very easily. But if you're using alum as a purifier, so it will do the coagulated substances like gel, so it will slightly impair your, if you're using the column filter, wire mesh filters. Instead you'll have to have the drying beds also only, because the filters will not be so advisable to be used in case alum is being used solely as the water purifier chemical. So these are the basic difference. Then basic actions, as you can see, of chemicals used in water treatment. Acid or alum, they do the pH maintenance. Acid, as you know, decreases the pH, and alum and lime increases the pH, makes it alkali. Acid makes it acidic. And general reaction, if you want to see how neutralizing the water, impure water, creates precipitation of the salts in the solution. Like if you have NaOH as a sodium hydroxide as a alkali substance, and if you put HCl, then you will have NaCl plus the water. NaCl is again a salt. So that's how acid, and putting acid and lime and neutralizing the water enables it to the chemicals to precipitate in forms of salts. Then alum is a fast flocculator or coagulator. Polyelectrolytes are again slow flocculation or coagulation. They do yeast and alcohols. They increase the life cycle time of the biodegradable substances or live bacteria in the water. Many times alum and polyelectrolytes are used together in a single dosing tank, so it gives a very good result, as well as it is economically practical. So we need around, if you ask the quantities, we need around 5 grams of this mixture for every 100 liters of effluent or sewer. However, the final quantities have to be established on site as per the lab test results. This is a slide which shows the parameters for water treated from STP or ETP. These are on the basis of the basic parameters available from CPCB sites. So you could see that the CPCB standard, what it says, pH should be roughly around 5.5 to 9 of the treated water. Then the TSS, or the total suspended solids quantity, should be less than 100. The unit is milligram per liter. It is roughly similar to ppm, parts per million. Then BOD, in case the effluent or sewage water consists of bacteria or biological substance, then the BOD is biological oxygen demand. It is more in case of the untreated water, because the bacteria has to go in through its life cycle before it becomes neutralized. So BOD is higher in the untreated water, but if it is less than 30, it says that generally it's considered that the bacteria is neutralized in the water. Similarly, COD is chemical oxygen demand. In the untreated water, in effluent treatment plant or in sewage treatment plant, COD is chemical oxygen demand, which talks of lots of chemicals being into the effluent or sewer water. And if it is less than 250, then it's considered that majority chemicals have precipitated or coagulated, got turned into flocks, and there is no major chemicals which is making water untreated or unhealthy, unhygienic. Then oil and grease, in terms of milligram per liter, the quantity should be less than 10. It could also be considered as ppm. Then heavy metal should be below the desired limit or designated limit, BDL, and here the BDL has been defined by CPCB, less than 5. Now I've given a note here. CPCB or the Pollution Control Board of the states do not say anything about TDS standards. However, for the potable water, it may be considered to be around 100 ppm or milligram per liter as good. These standards in general, what we have given in the table, are regularly updated by CPCB or the State Pollution Control Board. So what we have given here, they may differ from the latest. You should consult and refer to the sites before giving a formal training or pasting it on the place where an STP or ETP are installed. Now comes how to maintain your ETP or STP. So I have given here 6 simple points. Number 1, have a dedicated agency or an operator for ETP or STP installed at your organization. Number 2, make an annual preventive maintenance schedule for your ETP or STP. Number 3, daily note inventory of the water treatment chemicals, energy meter readings to ensure that it runs daily, water flow meter readings. Water meter must be installed after the tertiary treatment before taking it out from the system. Then pH, TDS and any other parameters of incoming and treated water which you can note easily at the ETP or STP. This is what training material I have given here. The entire training is based on a very simple mechanical type ETP or STP. You can have an automated controller installed STP or ETP also in the organization, because it can check the pH or TSS and TDS automatically and do the dosing of alter the dosing of the chemicals accordingly. But you have to have a dedicated operator to run it. Then 4 number is get the monthly test report from CPCB or local state PCB certified lab and submit at CPCB or local state PCB office regularly. Monthly you need to do it. In case the treated water is being disposed of on land for plantation gardening, etc., get the soil testing also in a monthly basis. Then number 5, dispose of the hazardous waste sludge collected in drying beds to the certified recyclers such as Ramki or Bhatal. We talked about it earlier, in sealed bags. Submit a copy of Form 10, which is prevalent currently in India, to the local state PCB office. In case, number 6 is in case you're pursuing ISO 14000 or OSAS, make aspect impact for ETP or STP separately and maintain hazardous waste board outside the gate of your organization. It's a must. for the organizations who are generating, hazardous waste.
Now we are showing you the functional homemade arrangement to explain the basics of water treatment. Here we have taken 2 beakers, each for untreated and treated clean water. We have done chemical lime and alum dosing in the first beaker itself. To transfer the water from the first beaker to the second beaker, we have fixed one 10 micron filter along with transfer pump. Here you can clearly see that the water is far cleaner in the second beaker. The TDS count has reduced from 2000 parts per million to roughly 800 parts per million.
Now we are talking about this is the last slide, we're talking about the references. References used in the training presentation have been inspired by website academia.edu. Then working of an effluent, the simulation model which we had shown was based on working of an effluent treatment plant built and installed by Messrs. Sophisticated Industrial Material Analytical Labs Private Limited, which is also named as SEMA Lab generally. And then number 3, ISO 14000 2015 manual. Thanks. Thanking you, I'm Amit Bhatia, and along with me there's Kanav, who has helped me preparing the simulation of this training program. For any feedback, please do write to us at kanavbhatia1997@gmail.com. Thanks. You can now take the feedback from your HR and fill in that as you do in the regular training programs. Thank you very much.